We think of hurricanes as powerful forces of nature here on Earth, winds that can level cities, floods that destroy communities. But what if I told you there are hurricanes in space, right above our heads, made not of wind and water, but of superheated plasma? And worse, like a massive dent in Earth's protective shield, could make us vulnerable to these cosmic storms. This is the story NASA doesn't want you to ignore: space hurricanes. The name sounds like something from science fiction, but they're genuine. And they're happening now, hundreds of kilometers above your head. Unlike the hurricanes we're familiar with on Earth, space hurricanes aren't made of wind and rain. Instead, they're massive vortex structures composed of swirling streams of energetic plasma, superheated, electrically charged particles that spiral through space at incredible speeds. So how do these cosmic storms form? It all begins with the sun. Our star constantly releases a stream of charged particles called solar wind. When this solar wind interacts with Earth's magnetic field in a very specific way, particularly when the interplanetary magnetic field is facing north, something extraordinary happens. Energy and plasma get funneled into Earth's upper atmosphere, creating these vortex-like structures. The result? A spiral storm of plasma, with what scientists call plasma rain, flowing down along magnetic field lines into the polar regions. It's like a hurricane, but instead of water falling from the sky, you have streams of electrically charged particles cascading toward Earth. Now, here's the critical question: are we in danger? In the most direct sense, no. Space hurricanes occur hundreds of kilometers above Earth's surface, and our atmosphere acts as a protective shield. You're not going to step outside and get hit by a plasma storm. But here's where it gets concerning, and why NASA is paying very close attention. Space hurricanes can wreak havoc on the infrastructure we've come to depend on. Satellites that provide our GPS navigation, telecommunications, weather forecasting, and internet connectivity are all vulnerable. These cosmic storms increase radiation levels and plasma density in space, which can cause electrical charging on spacecraft and satellites. Think about what that means for a moment. Your smartphone's GPS, dependent on satellites. Global communications, satellites. Weather forecasts that warn us about Earth-based hurricanes? You guessed it, satellites. When space hurricanes strike, they can damage or temporarily disable these critical systems. Spacecraft can experience malfunctions. Astronauts aboard the International Space Station face increased radiation exposure, and here on Earth, we could lose GPS signals, experience communication blackouts, and see disruptions in everything from air travel to financial markets that rely on satellite timing. But the story gets even more unsettling. Remember that protective shield I mentioned? Earth's magnetic field? Well, scientists have discovered a massive weakness in it. The South Atlantic Anomaly, or SAA, was first discovered in 1958. This isn't some small defect. We're talking about a dent in Earth's magnetic field that spans from Southwest Africa to South America. To put that in perspective, that's roughly the width of the Atlantic Ocean. NASA has been monitoring this anomaly for over 65 years, and they've called it a big headache for satellites, which might be the understatement of the century. So, what exactly is happening here? Earth's magnetic field is a protective bubble around our planet. This invisible shield stops the sun from vaporizing life as we know it. It repels and traps charged particles from space, allowing biological life to flourish. But something is very wrong in the South Atlantic Anomaly. The magnetic field is significantly weaker over South America and the Southern Atlantic Ocean. Instead of charged particles being deflected high above Earth, they dip much closer to the surface than usual. Think of it like a damaged umbrella. Most of the umbrella works fine, but there's a tear in the fabric over the South Atlantic, and the rain, in this case dangerous radiation and charged particles, is getting through. This has caused real problems. Satellites passing through this region frequently experience glitches and malfunctions. The Hubble Space Telescope has to shut down some instruments when it passed through the SAA. Even the International Space Station takes extra precautions when orbiting this weakened zone. Here's what keeps scientists up at night. The South Atlantic Anomaly is changing, and not for the better. Recent observations show the anomaly is splitting, deepening, and potentially expanding. The magnetic field in this region continues to weaken year after year. Scientists are still working to understand precisely why this is happening, though it may be related to Earth's molten iron core changes, which generate our magnetic field. But here's the terrifying part. As the SAA grows and deepens, we become significantly more vulnerable to space weather events, including space hurricanes. Imagine a powerful space hurricane striking Earth in an area where our magnetic shield is already compromised. The effects could be catastrophic for our technological infrastructure. We could see widespread satellite failures, GPS blackouts affecting everything from your smartphone to commercial aviation, communication disruptions impacting millions, and even power grid disturbances. And this isn't just theoretical, we've already seen what space weather can do. In 1989, a geomagnetic storm knocked out power for 6 million people in Quebec for 9 hours. Imagine that happening globally in our even more technology-dependent world today. Space hurricanes are real. The South Atlantic anomaly is real. And the vulnerability of our modern, technology-dependent civilization to space weather is very, very real. The good news? NASA and space agencies around the world are watching, monitoring, and working to understand these threats better every single day. But as we push further into the space age, building more satellites, planning missions to the Moon and Mars, we need to respect the power of space weather. Because while we've mastered hurricanes on Earth, predicting them, preparing for them, surviving them, the hurricanes above us are a different challenge entirely, and Earth's weakening shield makes that challenge even more urgent.